you by thesis123.com. I learn and teach online.
Here's the next question, number 36. A parallel plate capacitor is partially filled with glass of dielectric constant 4 as shown below. The dielectric strengths of air and glass are 30 kilovolts per centimeter and 300 kilovolts per centimeter respectively. The maximum voltage in kilovolts which can be applied across the capacitor without any breakdown is dash. Okay, so here we don't have options given to us. Let's write down what's given and we shall begin. So we have the dielectrics and the dielectric strengths and the dielectric constants given to us. So the dielectric constant is 4 for glass and the dielectric constant is 1 for air. So first let's write down the capacitance C1 with respect to the glass and with respect to air as well. So C1 is written as epsilon r into epsilon naught A divided by D, where A is the area and D is the distance or the width. So here for air, let's start with air. C1 is air. So here we have 1 into epsilon naught A divided by D, which is epsilon naught A by D. C2 is for glass and here the formula will be the same, divided by D, 4 epsilon naught A by D. So we have C1 and C2. Now the capacitance or the effective capacitance C equivalent would be both of them in parallel depending on, looking at the figure given here. So we can write it as C1 C2 divided by C1 plus C2. That's the effective capacitance. So C equivalent, let's substitute the expressions here. Epsilon naught A by D, 4 epsilon naught A by D into C equivalent. Here we would obtain 4 epsilon naught A divided by 5D. You can substitute and solve and check if that's the expression. You should get 4 epsilon naught A by 5D. Now let's talk in terms of electric strengths, dielectric strengths E. So for an electric field, E written in terms of capacitance C equivalent, we would have the product of the capacitance and voltage divided by the area times epsilon naught. So this equation, let's isolate V. So this implies V would equal to E A epsilon naught by C equivalent. Now let's substitute the expression for C equivalent. V is equal to E A epsilon naught divided by, we found that C equivalent is 4 epsilon naught A by 5D. So this results in 5E D by 4. This is the expression for the voltage. Now the question tells us to find the maximum voltage which can be applied across the capacitor. So here we will have to substitute the values for D and E. So E is given as 30 kilovolts, which is 30 into per centimeter. We will have to be careful here. We have to write it in terms of meters. So that's 30 into 10 power 3 into 10 square. Then we have D given to us as 5 mm. which is 5 into 10 power minus 3. Let's substitute these values. We get 5 into 30 into 10 power 3 into 10 square into 10 power minus 3 into 5 divided by 4. So V would equal to 18,750 volts, and that gives us 18.75 kilovolts. So the answer here is 18.75. 18.75 kilovolts is the right answer. Well, this is the solution and I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.